In this video, I solved two numerical questions of sampling distribution about mean when sampling is performed without replacement. Now let's start. Example. Here is the statement of question. Assume that a population consists of 7 similar containers having the following weights. Weights recorded in kilograms: 3.3, 10.2, 10.4, 9.8, 10.0, 10.2 and 9.6. Find the mean and standard deviation of the given population. Draw random samples of 2 containers without replacement and calculate the mean weight x bar of each sample. From frequency distribution of x bar and a sampling distribution of x bar, form the frequency distribution of mean and sampling distribution of mean. Find mean and standard deviation of sampling distribution of mean. So first we calculate first part, which is we calculate mean and standard deviation of population. Our population is this 3.3 to so on 9.6. We calculate this mean and variance. So the formula of population mean mu is equal to sum of x over n, sum of all 7 observations and divided by the total number of observations, which is 7. So the answer is 10 kg. At next step we calculate standard deviation. Its formula is sum of x minus xi minus mu whole square over capital N. So from each observation minus its mean and square. 9.8 minus 10, we left with 0.2 square. Similarly 10.2 minus 10 square and so on 9.6 minus 10 whole square over 7. After simplification, here we left with 0.48 and the number of observation is 7. The result is standard deviation 2.62 kg. So we solve first A part. Now B part. Draw random samples of 2 containers without replacement. We draw 2 containers from complete population using random sampling without replacement and calculate mean weight x bar of each sample. So suppose we named containers as A, B, C, D, E, F and G. So the number of possible random sample n is equal to 2. The formula to be used for total number of sample is 7C2. NC, we use combination formula for the calculation of total number of samples that we draw when sampling is without replacement. So capital N is, its formula is capital N, C small n. Capital N is 7. 1, 2, 3, 4, 5, 6 and 7. Small n is 2. 7C2. 7 factorial over 2 factorial, 7 minus 2 factorial. The total number of samples are 21. So the 21 possible random samples with values of their mean weights. Here is the table sample number. We have 21 samples. Here is the combination of sample. Because sample size is 2, first we combine A with B, A, B, then A, C with order. A, D, A, E, A, F, A, G. We see in table A, B, A, C, A, D, A, E, A, F. So AG. 6 samples are with A, AG. A is itself. Now we mark cross on A. We start with B and with the order make combination with each sample. BC, BD, BE, BF, BG. As you see, 5 samples are with B, B, C, B, D, B, E, B, F, B, G. Now cross on B. We start with C. C, D, C, E, C, F, C, G. Look here. C, D, C, E, C, F, C, G. Now cross on C. We go with D. D, E, D, F, D, G. 3 samples with D. D, E, D, F, D, G. Cross on D. We go with E. E, F, E, G, and then F and G. So 21 samples are completed. Here X1, which is put the observation of A is 9.8 and B 10.2. Similarly A 9.8, C 10.4, A 9.8, 9.8, D 9.8, A 9.8, E 10, 9.8, 10.2. So put the values of A both these numbers. When after this take the sample mean x bar. We take mean x bar, as you know, for taking of mean sample, add these two observation and divide it by 2. Means 9.8 plus 10.2 divided by 2, answer is 10. 9.8 plus 10.4 divided by 2, 10.1. 9.8 plus 9.8 divided by 2, 9.8. 9.8 plus 10 divided by 2, 9.9. Similarly, we get sample mean of this sampling without replacement that we made. So this is our sampling distribution of mean by using simple random sampling without replacement. And for last sample, as you see, 10.2 plus 9.6 divided by 2, 9.9. So for C, form frequency distribution of mean and sampling, form frequency distribution of sample mean x bar and sampling distribution of x bar. So the frequency distribution of x bar, first we made sample mean. The lowest value is 9.7 and the highest is 10.3. And these are the tally marks. Tally marks means the total number of each value appear. 9.7 appear 2 times, we 2 sign here. 9.8 appears 2 times, there is 2 sign. 9.9 appears 4 times, 4 signs. 10 appears 5 times, there are 5 numbers. As you can see, count the numbers and then write here. 10.3 appears 2 times 2. We see here 10.3. 1 time 10.3 is at this spot and 10.3. So 10.3 occurs 2 times. We write here 2 signs. These are the tally marks. F show the frequency. Frequency is the number of each observation occurs the total number of times. So write here 2, 2, 4, 5, 4, 2, 2. So this is the frequency distribution of x bar. This is the table of sampling distribution of x bar, because we draw our sample and adopt the procedure of sampling without replacement, make the samples, and then by using mean formula we get sample mean x bar. And then our next task is to make frequency distribution of x bar, which is this table. Now we made sampling distribution of x bar. Sample mean, that is lowest value 9.7 to 10.3, and here is the sampling distribution of x bar. 2 by 21, total number of observation is 21. So 2 by 21, 2 by 21, 4 by 21, 5 by 21, 4 by 21, 2 by 21, 2 by 21. Simple formula to make sampling distribution of x bar: divide this frequency to the total number of frequencies. Total number of samples or frequency is 21. So divide. When you add up 21 divided by 21, we left with answer 1. Now for part D, here we calculate mean and standard deviation of sampling distribution of x bar. Mean and standard deviation of sampling distribution of x bar. So the formula for mean: mu x bar right here in subscripts. This is used for mean of sampling distribution of mean. Sum of x bar, f of x bar. F of x bar represent the sampling distribution that we made in this table. This is f of x bar. So mean of x bar 9.7, which is the lowest value, 10.3 is the highest value. F of x bar 2 over 21, 2 over 21, 4 over 21. Write the f of x bar. These values obtained from this table, and then we multiply x bar with f of x bar. Here answer is 10. So x bar, f of x bar, 2 over 21, 9.7. 9.8 multiplied by 2 over 21, we have the answer 19.6. 9.9 multiplied by 4 divided by 21, answer is 39.6. 10 multiplied by 5, answer is 50 divided by 21. 10.1 multiplied by 4, 40.4 over 21. And then when you add up these values and divided by 21, your answer is 10. So we calculate mu x bar, which is 10. Sigma x bar is equal to sum of x bar minus mu x bar square f of x bar. X bar minus mu x bar. Your x bar is 9.7. Mu x bar 10. 9.7 minus 10 minus 0.3. 9.8 minus 10 minus 0.2. 9.9 minus 10, answer is minus 0.1. 10 minus 10, answer is 0. So on. 10.3 minus 10, 0.3. Now square these terms, x bar minus mu of x bar. So when you take square, minus 0.3 square 0.09, minus 0.2 square 0.04, 0.01, 0.01, 0.04, 0.09. These are x bar minus mu of x bar square. But we need here summation x bar minus mu of x bar square f of x. We multiplied this term with f of x bar. 2 over 21 multiplied by 0.09, 0.18 over 21. 0.04 multiplied by 2 over 21, 0.08. 4 multiplied by 0.01, 0.04 over 21. This is 0, and follow these the procedure. 2 over 21 multiplied by 0.09, 0.18 over 21. When you sum these terms, you have answer 0.6 over 21. Put this value here, 0.6 over 21, because this is the answer of sum of x bar minus mu x bar square f of x bar. And we got this term, we write this term here and got answer of this 0.6 over 21. So we left with 0.17 sigma x bar, which is smaller value indicate that sampling distribution of mean is more concentrated about the population mean. So we solve the first question. Here is the second question. This is the statement of question. First we read the statement and then we solve it. A sample of size 3 is to be randomly selected without replacement from a population that has capital N is equal to 5 items whose values are 0, 3, 6, 9 and 12. First is find the sampling distribution of sample mean x bar. First we calculate sampling distribution of sample mean x bar. Then calculate mean and standard deviation of x bar and verify. Sigma square x bar is equal to sigma square small n dot capital N minus small n over capital N minus 1. Let the items be designated by the letter A, B, C, D and E. We allot these 5 numbers A, B, C, D and E. Number are 0, 3, 6, 9 and 12. We draw sample size, small n sample size is 3 and sampling using sampling distribution without replacement. So for sampling distribution without replacement, the formula to draw samples are capital N C small n, capital N 5, C small n 3, 5 factorial, 3 factorial, 5 minus 3, 2 factorial. After simplification 10. So we draw 10 possible samples. So we made sampling distribution about mean. Here are the sample numbers 10. This is the sample combination because sample size is 3. So we first use A with AB. These two values combine AB with this C and then change the third value. And and consider the order. For example, A B C, A B D, A B E. As you see, we first select first two values A B C, then change the third A B D, A B E. Now we use combination cross on B with C, A C D, A C E, A C D, A C E. Now cross on C, A with A combination with D, A D E, A D E. Now we have used all combinations of A. Cross on A, use B, B C D and B with C and change the position of D with E. B C D and B C E, B C D, B C E. Now cross on C, B with D, B D E, B D E. Cross on B. We have left now 3 values. These are the single combination C D E at 10th position. So we draw 10 samples by using simple random sampling without replacement of sample size 3. So now put the values of A is 0, B is 3, C is 6, again 0, 3, 9, 0, 3, 12, so on for last C, D, E, 6, 9, 12. At this we calculate sample mean. As you know, to calculate the mean, add up all observation divided by the total number of observation. 6 plus 3 plus 0, 9. Divided by 3, answer is 3. 0 plus 3 plus 9, answer is 12. Divided by 3, 4. 0 plus 3 plus 12, 15. Divided by 3, 5. 0 plus 6 plus 9, 15, 5. 0 plus 6 plus 12, 18. Divided by 3, 6. 6 plus 9 plus 12. Divided by 3, answer is 9. Now we made sampling distribution of x bar. Here are the sample means 3, 4, 2, so on 9. This is the frequency. 3 occurs 1 time, 4 occurs 1 time, 5 occurs 2 time, 6 occurs 2 times, 7 occurs 2 time, 8 1 time and 9 1 time. As you can see, 6 occur 2 time, 5 occur 2 time, 7 2 time and the remaining numbers are 1 time. f of x bar 1 divided by total number of observations, which is 10, total number of samples, which is 10. 1 by 10, 1 by 10, 2 by 10, 2 by 10, so on, 1 by 10. Calculate mean and standard deviation of the x bar. As you know, the formula of mu x bar is sum of x bar f of x bar. Mu represent the mean of sampling distribution of mean. So here is the sample mean f of x bar that we calculate from this table of sampling distribution of x bar already. Now our task is to calculate x bar f of x bar. Multiplied these two columns. 3 multiply with 1 over 10, 3 by 10. 4 multiply 1 over 10, answer is 4 over 10. 5 multiply by 2 over 10, answer is 1. 10 by 10, answer is 1. 6 multiply 2 over 10, 12 by 10. 7 multiply 2, 14 over 10. 9 multiply by 1 over 10, 9 by 10. 1 multiply and 9 and we 9 multiply 1 over 10, 9 over 10. We add up all these observations, means 3 by 10 plus 4 by 10 plus 1, so on, 9 by 10. We have answer 16 and divided by 10, 6. Our answer is 6. 16 by 10, answer is 6. Similarly, for sigma x bar, summation x bar square f of x bar minus summation x bar f of x bar whole square. We already calculate this term, which answer is 16 by 10. Our task is to calculate x bar square f of x bar. So we x bar square, we square this column and multiply by this column, means 3 square, answer is 9, multiply by 1 over 10, 9 over 10. 16, 4 square, 16, 16 multiply 1 over 10, 16 by 10. 5 square, 5 square 25, 2 over, multiply by 2 over 10, answer is 15, 50 over 10, 5. So on, 9 square 81 multiply by 1 over 10, 81 by 10. So add up all these observations, which is sum of x bar square f of x bar. We have left with answer 39. Means the total is 319 divided by 10, answer is 39. And here answer is 6. 39 minus 6 square 36, 1.732, which is the sigma x bar. In order to verify your results, population mean is total observations as 5. When you calculate the mean of population, your answer is 6. Add up all observations 0, 3, 6, 9, 12 and divided by the total number of observations, and you left with answer 6. So population mean and mean of sampling distribution of x bar is equal. Mu x bar is equal to 6 and population mean is also equal to 6. This is the method to verify your results. Now we verify the variance, which is, its formula is sigma square 0 minus mean square plus 3 minus mean, which is 6 square, plus next observation 6 minus 6 square plus next observation is 9. 9 minus mean, which is 6 square plus 12 minus mean square over 1 over n. 1 over n is 5 because capital N is equal to 5. Total number of observation is 5. So your sigma square is 18 after simplification. So now verify the result. Sigma square over small n dot capital N minus small n capital N minus 1. Sigma square 18, small n 3, capital N 5 minus 3, 5 minus 1. You left with 18 multiply by 2, 3 multiply by 4, your answer is 3. So sigma square x bar is sigma square x bar, the answer of sigma square x bar, sigma square x bar is also 3. This is the answer of sigma x bar. When you square, its answer is 3. So sigma square x bar and say and this result is equal to sigma square over small n dot capital N minus n capital N minus 1, which is equal to sigma square x bar. Hence we verify the results. If you want to see videos about what is target population, MCQs about sampling distribution, then click the link in front of your screen. If you like the video, then click on like button and subscribe my channel Statisticians Club. Thanks for watching.